Good morning, 10th standard. So, in your previous classes, we had videos on chapter 4. So, let us have an outline of what and all you have learned in your chapter 4. So, chapter 4 is all about refraction of light at plane surfaces. Okay, it is going to be a plane, a regular surface, and we will see what happens in that. So the very first thing is you have to understand difference between refraction and reflection. Okay, refraction and reflection. So reflection means it's thrown out of one surface. When a light falls into a rough or a plane surface, it is sent back in another direction. That is called as your reflection. In case of refraction, here there is a change in direction of your light, change in the direction of a light, and it transfers from one particular medium to another particular medium. Okay, in case of reflection, both will be in the same medium, the both will be in your same medium, whereas in case of refraction, here the light will travel from one particular medium to another particular medium. So let us see this. You would have seen all this in your videos. I want to have a basic recap on them. So consider this to be a plane surface. When a light ray falls on it, and if it is going like this is called as your reflection. Okay, it is called as your reflection because it is happening in the same medium. There is no change in medium, if at all. And this is your air, and here it's a water medium. Consider this is to be as a water surface. So again, when a light ray falls on it, and if there is a change in its direction, this is called as your refraction. It's called as your refraction. So there is a change in its medium. The above surface is your air medium, and the below surface is your water medium, whereas in case of reflection, it is going to be the same one. So refraction is the change in the direction of light. In both the cases, it is a change in direction of light, whereas in case of refraction, the change in direction of light along two different media. So this is what you term as your refraction. So first question which will arise into you, why this refraction takes place, what is behind it? It is because of your density of the medium. So air is comparatively less dense comparing to your water. Because of this density, the speed of the light will tend to change. So in air, the speed of the light will be maximum, and in water, the speed of the light will be minimum. So can you recall what is the speed of your light? In vacuum, it is 3 into 10 power 8 meter per second. But once it comes into water, it will become 2 point. Okay, so it comes around 2 point into 10 to the power of 8 meter per second. So this change in the speed of your light waves due to the change in the medium is called as is your refraction. Okay, you all understood? So this change in the speed of the light due to the change in its medium is termed as your refraction. So now I understood about what is a refraction. Now my question is, whenever the light ray travels from air to water medium or from water to air medium, how does it will bend? Whether it will bend along the normal or away from the normal. So that I have to be clear. So these are the three criteria which states that whenever your light ray moves from one particular medium to another medium, what happens to it? So before going into it, we need to have a clear idea about a rarer medium and denser medium. Rarer medium is a one in which the speed of the light will be maximum. Rarer medium is the one in which the speed of the light will be maximum, and denser medium is the one in which the speed of the light will get minimum. So according to definitions, then you can understand, in air the speed of the light will be maximum, therefore it is your rarer medium. So obviously water, glass or any other medium in which the speed of the light tends to slow down is called as is your denser medium. So hope you are clear in this. So now look at these conditions. So the first condition, so can you see medium 1 and medium 2? What is your medium 1 here? Air. And in the medium 2 it is glass. So air is a rarer medium and glass is your denser medium. So now when a ray of light strikes from air to glass, you can see it is moving in this direction. Now if you draw a normal line, you will always find the refracted ray is towards this normal line. It's more towards your normal line. Okay, so it is always towards your normal line. So now look at this figure. You can see this is your incident ray. Okay, this is your incident ray and this is your refracted ray. This is your incident and this is your refracted. So this dotted lines actually show the path in which the incident ray has to move. But what happens? It has moved from this dotted line. So this angle is called as your angle of deviation. Okay, it is called as what? Angle of deviation. So if you didn't understand, I'll explain it here. Listen, you are having a ray of light which is passing like this. So and after the surface also it should pass in the same direction. But what happens? Because of your refraction, there is some deviation to its path. Okay, there is some deviation in this path. So this deviation, the angle how much it is deviated is called as your angle of deviation. So if at all it has to move in this direction, but here it is moving towards your green line. Why? Because of your because of your refraction. Okay, the change in media causes your refraction. So this change in the angle is called as your minimum, it's called as your deviation. So now let's go back to our diagram. There you can see angle I is greater than angle R. Angle I is greater than angle R. Therefore, your deviation formula should be I minus R. The deviation formula should be I minus R. So the next one, when a ray of light enters from a denser medium to a rarer medium. So once it comes to the rarer medium, the speed of the light will be maximum. So again, instead of going along the same path, what it will do, it will move away from your normal means this NM line is called as your normal. The 90-degree line is called as is your normal. So this is your normal line. So instead of coming along this path, what happens to your light? The light started to move in a different direction. So this is your refracted ray. So here I can see it is moving away from my normal. Can you see? So if this is my normal line, you can see your line has moved away from your normal. So angle R, that is your refracted R, will be greater than I. So in this case, the deviation formula is R minus I. You might be wondering why we need to study all these, because in the next lessons you have to plot, mark all these for a given prism. They will give a prism and you have to identify whether it is going from inside to outside, and accordingly you have to draw them. So the next case, if at all the line is going to come in a straight, okay, the incident angle is going to be normal. What happens in this case? So in this case there is no deviation at all. Okay, so when it comes along the 90-degree line, there is no deviation at all. The line will pass as such. These three criteria are so important, because for a given prism they will ask us to mark all these whenever, and so you'll be learning all these in your upcoming exercises. So finally, what is the cause of refraction? Okay, the cause of refraction is because the change in the speed of light in different medium. So once it moves from one medium to another medium, there is a change in the speed of your light. So that is your reason. So based on this, you will always learn laws. In your 8th and 9th, you would have studied about laws of reflection. So recollect it, the laws of reflection. Yes, so in the same manner, here we'll be studying about laws of refraction. So the next one is your laws of refraction. So refraction states the incident ray, the refracted, and all the normal at the point of incidence all lie in the same plane. So you can see they are all in the same plane. So your this is your incident, the refracted, and this is your normal line. So they are all in the same plane. Plane means one particular surface. So they are all in the same plane. And the next one, the ratio of the sine of angle of incident to the sine of refraction is constant for a given pair of medium. So it's a given pair of medium means, okay, it's something a constant value. For example, listen, here what is a pair of medium? It is air to glass. So here the light is traveling from air to glass, so for this your refractive index will be a constant value. But wherever when it travels from glass to air, for it will be a constant value. So understand, for a pair of medium means from where to where the light is traveling. So first case, it is from air to water, therefore sine I divided by sine r. So this refractive index is for air to water. Here it is traveling from air to water, whereas in the next case sine I by sine r, and this refractive index is from glass to water, sorry, glass to air. And here also it is not water, here it is glass, I'm sorry. Okay, so that is called as your refractive index. This ratio is called as your refractive index. So we denote using the symbol mu, and this law is called as your Snell's law. This law is your Snell's law. So using your Snell's law, we can find the refractive index for a given pair of medium. So your refractive index formula is speed of light in air divided by speed of that particular medium. Okay, so for which medium I want to find, I have to divide air, speed of light in air divided by speed of that medium. So first case I want to find for glass, so I have to know the speed of light in air as well as in glass. So it is 3 into 10 power 8 divided by 2 into 10 power 8. Now listen, here also it is meter per second, here also it is meter per second, so the units will get cancelled off. Next one, your 10 power 8 will cancel, you will have 3 by 2, which is 1.5. so the refractive index of glass, whenever a light travels from, yes, in a glass it is 1.5. Next one is for water. So water means speed of light in air divided by speed of light in water. So 10 power 8 will cancel. If you cancel this, you will get a value 1.33. All these values are constant, they are fixed. So like that, here they have done a calculation, a table which shows different refractive indexes for that particular medium. All these will be used in your higher classes. Maybe if you are doing any experimental, they will be using your refractive index. Suppose in case here air is not involved. Now consider a case where a light has to move from glass to water, and then it has to move from air. So here, if air is not involved, how do I write my formula? Therefore, speed of light in medium 1 to speed of light in medium 2. You consider you are just having a glass which is filled with water. I'm sending a ray of light inside. So here there will be a medium interference between your water and glass, again glass and air. So in that case, you have to understand speed of light in medium 1 divided by speed of light in medium 2. So there are some examples given here. Refractive index of glass with respect to water. So here it is, yes, refractive index of glass with respect to water. So medium 1 is water and the second medium is glass. Refractive index of water with respect to glass means it is glass divided by water. So always understand from where to where the light is moving, and accordingly we will divide them. So students, this is the outcome or like a conclusion which we have learned about all these. So as I told you, there are 3 conditions. First one, whenever it is moving from rarer to denser, it will move towards your normal. Denser to rarer, it will move away from your normal. So if it is coming along 90 degree, it will go in a same path. There is no direction. So therefore, the condition for no change in direction of light, there is no change in direction of light, what it should be, it should come along your 90 degree path. I don't want to change my direction of light, so it should go in a straight. So how should I send? Yes, I have to send in a straight path. I have to send my light in a straight path. So consider a prism where I don't want my light to get deviated. I don't want my light to get deviated. So how should I send my light inside it? I have to send it in a straight path. So if at all I make it to move in a straight path, it will go in a straight line. So here the angle should be 90 degree. It has to be sent 90 degree. One more condition, if both the medias are same. If both the mediums are same. So this is also going to be an air medium and this is also going to be an air medium. If I send the light, there is no deviation because they are all in a same medium. There is no deviation at all. So this is for no deviation condition. So whenever the speed of the light changes, there are some factors which will also get affected. The wavelength of the light will change, but not its frequency. Frequency is a source dependent one, whereas your wavelength will change according to your speed. So that you have to note on. So all these 4 points are important, which you have to note it down clearly. Factors affecting the refractive index. Factors affecting the refractive index. Next one is your nature of the medium. So how much denser it is. If it is moving from an air to water or water to glass, the density of the medium will affect it. The physical conditions such as temperature. With the increase in temperature, the speed of the light in a medium increases. Okay, with an increase in temperature. The color of the wavelength. The speed of the light of all colors is same in air or vacuum, but the speed of the light is different for different colors. So as depending upon the color, the speed of the light will change. So in a medium, red light travels faster than a violet light. Therefore, the refractive index of the medium is more for violet light and less for red light. So you can note these points. Okay. So either in terms of speed or in terms of your wavelength, you can note it down. So speed or wavelength, you can note on the principle of reversibility. Principle of reversibility. So look at here, a ray of light is moving along this path. The same ray of light can also move along the same path in an opposite direction. That is called as your principle of reversibility. So if I'm able to move from A to B, then the ray of light can also move from B to A. It can also move from B to A. The same can happen. There is no change at all. I'll explain your principle of reversibility here. So consider this as your air medium and this as your water medium. Now a ray of light is moving from air to water. So if it moves towards water, it will always move towards your normal. Yes or no? So this is how it is moving. So now I'm going to produce the same condition but in a different manner, where my ray of light is moving from water to air. So if it moves from water to air, it will always move in a away direction. From the normal, it will move. So this is called as your ray reversibility process. You can reproduce them back.